Okay, let's be clear. This is not just another incremental AI update. What we're diving into with Gemini 3 Pro is a really fundamental shift, a leap into what people are starting to call the agentic future. This one sentence right here, it perfectly captures the promise of this new era. You see, this isn't about writing code a little bit faster. It's about completely changing how we create. We're moving away from having to give step-by-step instructions and moving toward just describing what we want, the final goal, and letting the AI figure out the whole complex journey to get there. And we're not talking about a simple request. The prompt for this was incredibly detailed. I mean, it asked for things like volumetric fog that actually drifts realistically, a full day-to-night cycle that controls the sun and sky, and even simulated traffic with up to 400 cars, each with its own headlights. That is just an astounding level of understanding, both creative and technical, all from one single prompt. So how is this even possible? Well, it's because Gemini 3 thinks multimodally. It can actually look at a simple hand-drawn sketch, understand the layout, figure out what's a button and what's a text box, and then boom, it generates all the HTML, CSS, and JavaScript to turn that napkin drawing into a working app. It's literally translating a visual idea directly into code. All of this really leads us to a brand new way of thinking about these models. They're evolving past being just simple tools. They're becoming something much more like a creative partner. They don't just execute commands anymore. They understand your intent and help build out the solution right from the very beginning. And this whole new paradigm, it actually has a name, agentic coding. It's the AI's ability to take a big, high-level goal, like that 3D bridge we saw, map out a detailed plan on its own, and then generate the entire runnable project. This is about real reasoning and planning, not just, translating syntax from one language to another. So the big question is, how on earth is this actually possible? Let's peel back the layers a bit and take a look at the core architecture that's making this new level of intelligence a reality. These incredible capabilities are really built on three key pillars. First, a unified multimodal architecture that lets it see the world more holistically. Second, a massive context window so it can hold a ton of information at once. And third, a brand new reasoning engine they're calling DeepThink, which is designed for tackling the really, really hard problems. Let's start with context, because this is wild. Gemini 3 can analyze up to 900 separate files. We're talking text, images, even videos, all inside a single prompt. Just stop and imagine what that means for trying to make sense of a huge, fragmented company data set or a super complex research project. And the reason it can handle all of that is because of this number, a context window of over 1 million tokens. This lets the model hold an entire massive codebase or a huge legal document in its working memory and reason across all of it at the same time. All right, now for that new reasoning engine, DeepThink. Honestly, the best way to get your head around it is with this analogy. It's like giving a brilliant student extra time and a whiteboard for a really tough problem. When the model gets a difficult query, it just uses more computation. It gets to think longer and work through all the complex steps it needs to. And what's really crucial here is that developers get to control this whole process. Using a parameter called thinking level, they can crank it to high to get maximum accuracy on those mission-critical tasks. It's a conscious trade-off between cost and speed, and it offers a whole new level of fine-grained control over the AI's reasoning. Okay, so the capabilities sound amazing, but what does the data actually say? Let's switch gears and look at the benchmarks, the hard quantitative proof behind this leap in performance. Now, in the AI world, the El-Amina leaderboard is a huge deal. It's basically a blind taste test where thousands of humans vote on which AI gives better answers, without knowing which model is which. Well, Gemini 3 Pro scored a groundbreaking ELO of 1501, putting it at the absolute top for general proficiency. But where it really shines is on these PhD-level tests. It set a brand new high score on a benchmark called Humanity's Last Exam. I mean, this is a test covering everything from quantum physics to philosophy that is so difficult, it stumps most human experts. That's a massive validation of its abstract reasoning and really sets a new standard for complex problem solving. Of course, a model this powerful brings up a huge question of responsibility. So how do you build these kinds of capabilities on a foundation of safety and trust? Let's take a look at the framework. So Google uses this really rigorous four-step process. First, they identify potential risks. Then, they model how those risks could be exploited.
After that, they assess the model's abilities against specific thresholds, and finally, they deploy safeguards. It's a very methodical, structured approach to managing risk. And here's a look at that assessment in action. This chart shows the results from tests for dangerous biological and chemical knowledge. Now, I know it looks a little complex, but the key takeaway is simple. In every single category, the performance of Gemini 3 Pro, that's the bar in orange, did not reach the level that's defined as a critical risk. This quote from the safety report really sums up their findings well. The model offers minimal uplift. What that means in plain English is that it does not make it significantly easier for bad actors to cause harm than just using the information that's already publicly available on the web. But here's the thing about AI safety. There's this core tension. It's a real tightrope walk. On one side, you have to prevent jailbreak attacks, where people trick a model into saying something harmful. But on the other side, if you make the safety filters too strict, you get what's called over-refusal, where the model refuses to answer perfectly safe questions. It's a really difficult balance to strike.
So this is where some really cutting-edge research comes in. One fascinating solution they're exploring is something called the magic image. Remember how the model is multimodal? It processes images and text together? Well, researchers found they can create a specific, optimized image that, when you feed it to the model with a text prompt, it acts as a kind of safety signal. It helps the model better distinguish between a malicious query and a safe one, which boosts security while cutting down on that frustrating over-refusal.
And that brings us right back to the central theme, doesn't it? We've seen AI evolve from a simple tool into an agent, a partner that can plan and reason and create. So the biggest question we're left with is this. As we build out this new agentic future, how do we make absolutely sure that this powerful new partner remains a trusted and responsible one?